So this video will be about transferring variables from truth table into a K-map. K-map will be used for minimization instead of Boolean algebra. K-map can be used. K-map is Karnaugh map. So I will start with 3 variable truth table. A, B, C are the 3 inputs and X is the output. So we will see that each cell of what each cell of a K-map represents. We will try to see. So let's say this is the K-map here, which is a 3 variable one. So we are saying this is A here, which is the most significant here, and this is A bar. So basically this is the binary 0, this is decimal. If I write in decimal, 0, 1, 2, 3, 4, 5, 6 and 7. When we transfer, each cell will represent one of the input, one of these. So maybe 0, then 1. So this is binary decimal, and this is binary. So we'll see how each cell represents what. So basically what happens, this is 0 here. I need to correct one thing, which is this one will be A bar here and this one will be A here. Okay, so and in this case this one will be B bar, C bar, which are the lower two significance bits, and B bar C, B C and B C bar. Now we can see this is going B bar C bar. If I write in terms of 0 1, this is 0 0, this is 0 1, then it's going 1 1 and then 1 0. So in terms of binary, I can write here, this one is 0 0 0, this is 0 0 1, this is 0 1 0 and this is 0 1 1. Why is it like that? I will say soon. This one is 1 0 0, 1 0 1, 1 1 0 and then 1 1 1. So in terms of decimal, I can write this is 0 here, then 1, then 2 is going here, and then 3, then 4, 5, 6 is again here, and 7. Now each adjacent cell, if we observe, we will see that the difference from this one to this one, there is only one bit is changing. So this one is changing from here to here. Similarly, from here to here, if I look, only one bit is changing, that is this one, this one. Now why after this one, after 1 here, it is 3 here, if we want to look at that? Because 1 and 2, if we look at 1 and 2, between these two, we will see this one is changing and this one is also changing. So they are not adjacent, and that's why in the K-map is made in such a way that 2, instead of coming right after 1, it is coming here in this place. So from 1 to 3, we can see the change is from 1 to 3, only this one is changing. So the change is only 1. So the benefit of that is it helps to minimize. Similarly, even from here to here, we can say this one to this one, the only change here is this one. So if we rewrite this whole thing in terms of A, B, so this one will be, this block will be, so what I will do, instead of this one, I will write A bar, B bar, C bar. This one will be A bar, B bar, C. This one will be A bar, B, C. And this one will be A bar, B, C bar. This one will be A, B bar, C bar. This one will be A, B bar, C. This one will be A, B, C. And this one will be A, B, C bar. Now, when we minimize, when we use the K-map to minimize, what happens is we transfer these outputs only once here, we transfer here, and then we form a group with the adjacent cells. So basically the group can be of 2, 4, 8 and well, if it is more than 3 variable, that is if it is 4 variable, there can be 16 as well. So basically a power of 2. So depending power of 2 to the power 0, 1 or 2 or 3. So 2 to the power 0 is 1, so it is grouping by itself. So basically in this one there is a 1 here, there is a 1 here, which is the first one. There is a 1, so this one is a 1 there, and then there is a 1 here which is 100, which is the 4. This one is a 1 there, and the last one, which is 7, is a 1 there. Everything else is 0. Now this one and this one can be a group. And why it can be a group? When the group forms, these two together, this one and this one, it's getting clumsy, but I am just drawing it. What I will do, I will just redraw this one. So 1 is here, here and here, and when we form these two as a group, because there are 2 of them, why it is minimized? Because this one is A bar, B bar, C bar, and this one is A, B bar, C bar. Now in terms of, if we didn't do it with a K-map, if we had used a Boolean algebra, it would be B bar, C bar there, and A bar plus A. That means it would be only B bar and C bar. So because A plus A bar is a 1. Now when we do use K-map, what happens is, this A bar and A is common here, so this group, the expression for this group becomes only B bar, C bar, because these two are coming as a common. Similarly, if we had a 1 here, which this truth table doesn't have, but let's say we have a 1 maybe here as well, so it can go with this one, can go with this one again. So the group will be A is here, and common here is only B. C and C bar is not common. So here A and A bar is not common, so this is not coming. And I don't know if I said this is common here. Actually this is not common because it's changing. So what is changing does not come. Here C and C bar is changing, so it doesn't come. So the common thing will come. For this one the group will be A and B. Now in terms of Boolean algebra, what it would be, this term, this one is A, B, C, and this one is plus A, B, C bar. So again, in terms of Boolean algebra, strictly without the K-map, we would have written like this one, C plus C bar, and that would give AB. So this is exactly what the K-map is doing instead of going into the algebra, but this is just forming a group here, and this would give here, this would give A here, which is common, and B here. So the things that are not changing or staying the same is coming in the expression, while which is changing, C, C bar, that wouldn't come. However, this group can also be this one and this one. These two could be grouped, because even if we look at these two, it will be here. We can see that A is again common. So we'll use maybe another color, maybe deep green. So A is again common here. And for this one and this one, we can see that C bar is common. C bar is common. So basically it would become A and C bar. B is changing, so it's becoming B and B bar, so it would not be. So if this whole thing would be in Boolean algebra, we would get, so this one would be A bar, B bar, C bar, plus A, B bar, C bar, A, B bar, C bar, and this one would be A, B, C, A, B, C, and this one would be A, B, C bar, plus A, B, C bar. So if we try to minimize this one, these two will become C bar here, so B here, sorry, this one is A bar, B bar, C bar, so yeah, A bar, B bar, C bar. So these two, what I can do, I can take B bar, C bar as common, it becomes A bar plus A in terms of Boolean algebra, and from these two I can take A, B as common, so it becomes C plus C bar. So it's becoming B bar, C bar plus AB, which is from Boolean algebra. The same thing we are getting from the K-maps. So we are forming this group and this group. Now we have to form this group because we have to take all the ones at least once. So if I form this group, this one, then this one will be left alone and I have to take this separately. That would give an extra term which is not needed, which is not the minimized one. So we shouldn't do that. We should try to take as less number of groups as possible. So minimum number of groups, and one group as large as possible, as big group, as big as a group is possible. We want to try to accommodate as many ones as we can. So anyway, I have done actually already few examples, but this is just the theory. I will do another video for the 4 variable ones.